Okay, so our next set of practice problems, we're going to be solving equations using those rational numbers. Okay, so we're told to solve these, which basically means that we're being asked to, get the variable by itself. And we've been doing these for a while, so this should be easy to do. You'll know that we always go to the opposite. So this first one has t is being multiplied by 2/5. So that means, of course, we would divide each side by 2/5. And I know that these, of course, would cancel. So that would leave me with t equals 6 divided by 2/5. I get to do the math Macarena. Woohoo! Okay, get to do the math Macarena, like I said, so we get to keep the first, flip the second, then you multiply. So we keep the first, flip the second, then you multiply. Keep the top with the top and the bottom with the bottom. So, oh, whoa, I changed that to a 3. Wait a second. Let's fix this first. This is not a 3. Glad I caught that before we went too far. That is a 5. Okay, now we multiply. So 6 times 5, of course, is 30. 1 times 2 is 2. That little 2 is too little to hold up that big giant 30, so 30 divided by 2 is 15. So in this particular case, we know that t equals 15. There's the first one. Next, okay, so this is a subtraction problem, and we now always ask ourselves, what's the opposite? The opposite of -8, of course, is +8. And we do that on both sides of our equation. These cancel, so that means I'm going to have a equals -4.5 plus 8. I'm adding. If the signs are the same, find the sum. Nope, they're not the same. If the signs are different, find the difference. So we will, of course, find the difference here. We need the absolute value of both of those. I already know that both of them are going to be positive because they're looking for a distance, and a distance can't be negative. So then I've got 8 minus 4.5. Well, I know that 8 minus 4 would give me 4, and then I still need to take away the 5/10. So 4 minus 5/10 would give me 3.5. And then I have to go back over here to look and see what sign I'm going to use. So 8 would have the larger absolute value, so the answer is going to remain positive. So therefore I've got A equals positive 3.5. Okay, next. Getting p by itself, so this is a positive 1/2, so therefore I'm going to subtract 1/2 from both sides. These cancel, so that means I'm going to have p equals -3 minus 1/2. Stay, change, cha-cha-cha. So that would be stay, change, cha-cha-cha. And now the signs are the same, find the sum. So I'm going to add those up. I've got 3 plus 1/2 is 3 1/2. And that sign stays exactly the same, so it would be negative. So the answer here would, for the final one, would be p equals -3 1/2. Okay, next I've got 12 equals x times 3. What's the opposite of times 3? Well, of course, divide by 3 on both sides. These cancel. This one's very easy. I'm left with x equals 12 divided by 3 is 4. There's that one. And then we've got the last one. What's the opposite of times negative 3? So, of course, divide by negative 3, both of them. These cancel. So that means y equals negative 12 divided by negative 3. Well, 12 divided by 3 I know is 4. A negative and a negative, there's two negatives. That is a positive because those two negatives like to be together. And there's our final answer. Easy peasy. Next, evaluate each expression if x is 2/5, y is negative 4, and z is negative 0.2. Okay, so we've got x is 2/5. 2/5. That is icky. Plus negative 4. Signs are different. Find the difference. Okay, then. So that means I'll have 4. I'm going to just switch them around because 4, of course, is the larger absolute value. Let's not forget that's what I'm doing with both of these. So I'd have 4 minus 2/5. Now, you can certainly go through, the whole thing, finding the least common multiple, using our acronym, I love eating apples and avocados, because everybody does. But really, if we just stop and think about this for a minute, we've got 4 whole things. So 4 whole pies, 4 whole pizzas, $4, 4 anythings. And we're taking away 2/5. So we're taking away part of one of those 4. So that for sure is going to leave us with 3 wholes. And then if I've got 1 whole and I take away 2/5, that's like saying 5/5 take away 2/5. That, of course, leaves me with 3/5. So then the only other question, is it positive or negative? So I go back here and I look at both of these. This, of course, would be the larger absolute value, which is negative, so therefore the answer is negative. Next problem. Okay, so for this problem, we have 2 times x, or 2x. So 2 times 2/5 minus z, which is negative 0.2. Okay, so I can't forget my order of operations. In this particular problem, I've got a multiplication part to the problem and subtraction. So I know multiplication comes before subtraction. So I've got 2 times 2/5. So I don't need to do any flipping because it's not a division problem. I go right to the multiplying. 2 times 2, of course, is 4. 1 times 5 is 5. See how we kept the top with the top and the bottom with the bottom. And now I know I'm subtracting negative 0.2, or negative 2/10. Okay, well, I know that 4/5, if I thought of that in tenths, well, there would be 2/5. 5 times 2 is 10, and 4 times 2, so that would be 0.8. 0.8. If you got confused on that step, please make sure you come and see me. 0.8 minus negative 0.2. And this is fun because I get to do the cha-cha-cha. Stay, change, change, cha-cha-cha. Stay, change, change, cha-cha-cha. So I got 8/10 plus 2/10. Well, that, of course, is 10/10, which is, or if you want to think about this like money, that's the other thing to do, is 80 cents plus 20 cents. That would equal $1 whole, or 10/10 equals 1. So there's our answer. Okay, the next one. We've got x plus y plus z. X plus y plus z. Well, wait a minute. X plus y We already did that. It's right up here. I don't like to redo my work, do you? That's just silliness. So I am going to do that first. I'm just going to bring that right down. My negative 3 3/5. It's right here. That's fine to do just as long as you show your work so that it makes sense for when we check it. So negative 3 3/5 plus z, which is negative 0.2. Oh, we've got those beautiful, wonderful fifths, which are so easy to change into tenths. So I know 3/5 is equal to 6/10, right? Okay, so I know that my 3/5 is the same as 6/10. So that is going to equal negative 3.6 plus negative 0.2. And then, of course, I know if the signs are the same, find the sum. And they, of course, are the same. So I've got 3.6, or 3 6/10, plus 0.2, which is 2/10. So 6/10 plus 2/10, of course, is 8/10. So that's 3 8/10, or 3.8. And both of them are negative. So it's negative 3.8. And now I've got y times x. So y is negative 4 times x is 2/5. Oh, this is so fun. Okay, so easy peasy. I put this right over 1, and then I get to keep the top with the top and the bottom with the bottom. So that's 4 times 2, of course, is 8. And 1 times 5, of course, is 5. And that 5 is too little to hold up that 8. So how many times does 5 go into 8? It goes into it once, with 3 left over. And that, of course, is 3/5. And I can't forget that there was a negative times a positive, which gives us a resulting negative number. And there is our final answer, negative 1 3/5. Okay, next problem. We're going to match each equation to a step that will help solve the equation. Ah, well, this is fun. We know how to do that. We always just ask that question. What's the magic question? Oh, what's the opposite? So this first one says 5x. Well, that's 5 times x. What's the opposite of times x? Well, that would be to divide by, not times x, times 5. So that would be to divide by 5 both sides. So none of those say that. Which one of these is the same as dividing by 5? So the question we ask is, dividing by 5 is the same as multiplying by 1/5. Here it is. So 3 would go here with A. Okay. B, I've got x divided by 5. What's the opposite of dividing by 5? That, of course, would be multiplying times 5 times 5. So this one would be multiply each side by 5. It would be here. That would be number 1 for this one. Okay, this is 3 equals negative x divided by 5. Well, I could simply multiply both sides times 5, but that presents us with the negative still being left in place, which we can't have. So that means I'd have to multiply both sides by negative 5, because on the right side, if I multiply by negative 5, a negative times a negative is a positive, which is what we want that x to be. So this is multiplying by negative 5. There it is. So this is number 2. Now, we can just assume that this one is correct. This last one, D should be matched with 4, but we really should double check. So what's the opposite of times times negative 5? Well, that, of course, would be divide by negative 5. And none of these over here say divide. So we know the same, dividing by -5 is the same as multiplying by that -1/5, so that would be 4. So again, our matches are A with 3, B with 1, C with 2, and D with 4. The markings on the number line are evenly spaced. Label the other markings on the number line. Okay. Well, I know from 0 to -1, this is the halfway point. So halfway between 0 and -1 would be -0.5. If we continue, by 5/10, this would be -1.5. This would be -2, and that works nicely because there's my -2.5. And now I need to go in the other direction on the number line, which means they're all positive. So this would be 0.5, 1, and 1.5. In 2012, James Cameron descended to the bottom of Challenger Deep in the Marianas Trench, the deepest point in the ocean. The vessel he rowed was called DeepSea Challenger. Challenger Deep is 35,814 feet deep at its lowest point. Wow, that was crazy. That is down into the ocean, the same as a plane flies straight up in the air, actually a little bit higher than that for the most part. So think about that. That's crazy. So the descent was a change in depth of -4 feet per second. And here's my equation. We know how to write equations. Y equals -4x to model this relationship. Y is the depth, x is the time. Okay. How many seconds does this model suggest it would take for the DeepSea Challenger to reach the bottom? Well, of course, to do this, I would divide. So I know I've got 35,814 divided by -4. Oh, it's negative, obviously. Sorry about that. So when I solve a problem like this, I need to, start from my left. 4 does not go into 3, but it does go into 35. 4 goes into 35 8 times. 8 times 4 is 32. 32 with 3 left over. 4 goes into 38 9 times. 9 times 4 is 36, so that gives us 2 left over. 4 goes into 21 5 times. 4 times 5 is 20. That's 21, so there's 1 left over. 4 goes into 14 3 times. 3 times 4 is 12. So I'm going to put a 0 on there. 14 minus 12, of course, there's 2 left over. I need my decimal here. 4 goes into 25 times. And that's a negative divided by a negative. So that is 8,953.5 seconds. Okay, next. To end the mission, DeepSea Challenger made a 1-hour ascent. Ascent, that of course means to go up to the surface. How many seconds is that? Okay, how many seconds in 1 hour? So I know that there's 60 minutes in an hour. And I know that there's 60 seconds per minute. So that would mean I'm going to multiply these together. 60 times 60, well, 6 times 6 is 36. Can't forget those zeros. So that's 3,600 seconds. And our last question. The ascent can be modeled by a different proportional relationship, y equals kx. What is the value of K in this case? Well, K, of course, would be the number of seconds, or excuse me, the depth, which is 35,814, out of the number of seconds, which would be 3,600. So that actually is K right there. And I know mostly in our purple books we're not using our calculators, but if you did solve this in your calculator, you would get 9.95. So that would be K. The constant is 9.95. Or you could have just left it in this fraction form. You could have reduced it, but it's fine.